This lecture seems ill-fated. I'm going to continue it on a video so that this way, when we come to class on Friday, I can briefly talk about the papers and get into gluconeogenesis. We're going to look at, we've already looked at PFK in the muscle, and we've seen that ATP will bind an allosteric site, okay, and it will reduce the affinity of PFK for the substrate fructose 6-phosphate. AMP will activate this enzyme. Okay. So muscle PFK is sensitive to ATP and AMP. I said there were 3 enzymes that are regulated in glycolysis. PFK1, hexokinase, and pyruvate kinase. Okay, PFK1 is the gatekeeper. Hexokinase phosphorylates glucose 6-phosphate, glucose to make glucose 6-phosphate. Okay. The reason why this enzyme is not the committed step is because glucose 6-phosphate has other fates. Alright, so hexokinase is inhibited by its product. So hexokinase is inhibited by its product, glucose 6-phosphate. Now, high concentrations of glucose 6-phosphate signal that the cell no longer requires glucose for energy or for the synthesis of glycogen, which is a storage form of glucose. So just to recap, when we have high glucose 6-phosphate, hexokinase is inhibited. So this will slow down glycolysis because we don't need energy. And it will also slow down glycogen synthesis, which is a storage form of glucose. A rise in glucose 6-phosphate concentration is also a means by which phosphofructokinase communicates with hexokinase. When PFK is inactive, the concentration of fructose 6-phosphate rises. In turn, the level of glucose 6-phosphate rises because it is in equilibrium with fructose 6-phosphate. So hence, when we have PFK inhibited, this will also lead to the inhibition of hexokinase. So let's just write this down. Alright, so because hexokinase is inhibited by glucose 6-phosphate, This provides a means of communication with PFK. Now, when PFK is inactive, then we have an increase in fructose 6-phosphate. Fructose 6-phosphate is in equilibrium, or this isomerization, I should say, is in equilibrium. So as the fructose 6-phosphate concentration increases, then the equilibrium will shift to make more glucose 6-phosphate. So this tells hexokinase to slow down. Now, we may have already talked about this, but I'm just going to bring it up again. Why PFK? Why is this the pacemaker or the gatekeeper of glycolysis, as opposed to hexokinase? And the reason is because, as I said before, glucose 6-phosphate is not solely an intermediate of glycolysis. Okay. Glucose 6-phosphate can be used to make glycogen. So because glucose 6-phosphate has other fates, it's not the committed step. Fructose 1,6-bisphosphate has only one fate. Once it's made, it is committed to glycolysis. And that's why PFK is the gatekeeper of glycolysis. The last enzyme we're going to look at is pyruvate kinase. Pyruvate kinase phosphorylates ADP into ATP. The inorganic phosphate comes from PEP, or phosphoenolpyruvate. So one product is ATP, the other product of this reaction is pyruvate. This enzyme is going to be inhibited allosterically by ATP in the muscle. It is also inhibited by alanine. Alanine is an amino acid, and it can be synthesized in one step from pyruvate. And so it also is going to allosterically inhibit pyruvate kinase. Okay. When alanine is present, it signals that the building blocks are abundant. Pyruvate kinase will be activated again by fructose 1,6-bisphosphate. So once we make more fructose 1,6-bisphosphate, this says, okay, amp up glycolysis. We need more intermediates. Alright, so this figure is summarizing the regulation of glycolysis in muscle. On the left, we can see where we have inhibition. So we started out by looking at PFK, and we can see that PFK is inhibited when we have a high ATP to AMP ratio. Then we looked at hexokinase, which is inhibited by its product, glucose 6-phosphate. In the muscle, we have pyruvate kinase, which is also inhibited by a high ATP to AMP ratio. And it's inhibited by alanine, which is not included here. When we look where glycolysis is stimulated, we can see that when we have a low ATP to AMP ratio, meaning we have high AMP, then we will activate PFK. Right. Pyruvate kinase is also activated by fructose 1,6-bisphosphate, saying keep up the flux of intermediates. In the forward direction.